Yeah, hi. So today's demo is about analyzing velocity functions, seismic velocity functions using Jupyter Notebooks. So I have this location where I've kept this velocity file, and let us see how we can import this into Python. So before we start, a brief overview. The three main libraries that we'll be using in Jupyter Notebook are NumPy, Matplotlib, and Pandas. So NumPy is used to process, this 3D array of numbers. This could be your, seismic cube, or it could be just a seismic line, anything which can be arranged as an array. So that's NumPy. Then Matplotlib is the main plotting library that we have. There are functions like plot. You could plot an equation using this. There is a function called hist, which can plot you a histogram, and a function called scatter. Much more. Pandas has some functions which are super easy to use, like reading a comma separated file in one line, exporting a comma separated file in one line. And Pandas, it works on objects which are known as data frames. So if when you open an Excel file, the 2D table that you see for Pandas, that 2D table is a data frame. So I'm going to say import the Pandas library as PD. You could name this as X or whatever, but let us follow the convention. What most people do is they call it as PD. And when you press shift and enter, you move on to the next cell. Either ways, you could use this run given here, but I generally press shift and enter key together. All right. Let us declare a variable called df. This again could be y, x, z, anything. Let us call it df, short form for data frame, and give it the location where we've kept. So I will use pd dot read csv function, all right. Let us pass as a parameter, let's pass the path of this. So this will be, so I will pass the path and append it with an r here. So like most languages, this is a string, the path is a string, and you put an r. And suppose these functions are called, so my velocities, my velocities dot txt. All right, let us see, shift and enter, and then shift enter and see how this has been read. So this file is a large file uh, with an id column in x, y location, time starting from 0, and velocity, the picked RMS velocity. Also tells you how many rows and how many columns. There are two functions which can help you quickly check whether everything is okay. One is called df.head, which show me the first few lines of this file, and the next one is df.tail. Pretty easy. Yeah, shift enter. All right. Next, you could selectively check what is inside each column. So I can pass within single quotes. Let us see what is there in x. So x is shown, and then check what is there in y. Carry on forever, I mean. Let's check time. Similarly, you could check the last column. Shift and enter and move on to the result in the next cell. If you want to check what type of object you've been using, say type and then pass this df here, and it tells you that this is a pandas data frame. Having successfully read this file, next let us convert this pandas data frame into a numpy array. So doing this will give us access to more functions. Okay, this is how you write a comment with a hash. For example, let us make a new variable and let us call it my time. There is a variable in the file which is called as time. So I will say use the time uh, you know so use the time variable in the file and take its values, convert them to a new variable called my time, and let us check the type of my time. This should not be now a pandas object, it should be a numpy thing now. Yeah, so it is converted to an n-dimensional array, a numpy array. Similarly, let's make a variable called my velocities into my velocity. Choose the velocity which is there in the file and take its values. Check the type of this newly constructed variable, and again, so you see that we've made two n-dimensional n numpy arrays for the purpose of plotting actually. So the plotting library is called matplotlib. At this moment, import matplotlib.pyplot as plt. You could use sy, lz, anything, but the convention is to use, most people use dot as plt. Alright. Now once you have imported the plotting library, it is possible to plot any two variables. So let us use these two. So my velocity is on the x-axis, my time is on the y-axis. Let us see if this graph makes any sense. Alright, let me scroll down. This is useless for us, because in earth sciences our 0 is at the top, and the depth should increase to the bottom. Alright, so let me correct this. How can I do that? So this axis, the y-axis or my time axis, I have to flip. Flip means multiply by -1. So I will write plt.plot my velocity plotted with my time times -1. Alright, one step ahead, but still I don't want this line joining the first and the last points in my function. Alright, for that, instead of the line in the plot, you could cross plot, say, my velocity with my time times -1, and okay, now I want blue and plus sign. So my color, let us choose points which are blue in color, and the points will be labeled with a plus. So voila, we have the velocity functions on screen. What if you want, in case you wanted, this in yellow color, what could you do? So you could plot velocity on x, my time on y, and flip the axis so that depth is increasing downwards, and as an additional parameter you say I want the yellow colored, instead of a plus you could say O, and yellow colored O's. So let us see. That's your velocity functions in yellow colored holes. I'm almost crazy. Let's not stop here. I spend more time changing colors on this plot. Now let us choose magenta colored infra magenta stars. So let us see what happens. Cool. So if you remember, for making this array, we had used a pandas uh, column called as velocity, df velocity. All right. Let us check. I mean, we could have done this earlier, but now that it occurred to me velocity, let us check the histogram. So a simple function hist and check what it shows us. All right. We could have more control on this histogram if I would use, I've used pandas. Let us use, so using pandas. Let's use matplotlib because that's the main plotting library. So let us say plt.hist, pass the variable which will be the array, the numpy array, and also because these were some 2200 points, so square root of that, let's say roughly 50, you could say 45 or whatever. So this would be a better histogram because of honoring the rules of stat. The number of wins, the number of wins should be under root of number of samples. So if you analyze this, these are velocity functions, RMS velocity functions, and it seems reasonable because starts at around 1500, 1400 something, and then there are major zones here, centered with a scatter. So 1, 2, 3, 4, 5, 6, 7, some 7 picks maybe, pretty good. All right, you could play with this a bit. You could also plot other things. You could say plt.plot. You could plot my time, so 45 pins, my velocity. Yeah, sorry. So I have to choose histogram, not really plot. Plotting is between two variables. So here we go. Next, let us edit some velocities. Okay, shift enter. So those of us who have run migrations, we never do migration with a single velocity. We we assume that humans make errors in picking, and the velocities can be plus minus 1%, plus minus 3%. To be dramatic, let me show you how to increase the velocities by 10%. So let us increase velocity, the RMS velocity by 10%. So how could you do that? Let's write an equation. So my increased velocity, or let us call it my velocity plus. My velocity plus is equal to, so my increased velocity is, these are, we are working on numpy arrays. So my increased velocity is basically my velocity, sorry, plus 10%, which is 0.1, times my velocity. All right, and press enter. And you could check what has been done. So there is a new array generated, and our earlier array, if you remember, when we were playing around with my velocity, velocity starts at 1483 or something. That's what processors do. the seabed something around 1450 to 1530. So we have increased that by 10%, and now this starts with 1630. Let us see the effect in a plot. Let's plot old velocity and new velocity, which is increased by 10% in the same graph, in the same plot. So let us say plt dot plot. There was a my velocity which was on x-axis and my time which was on y-axis. We had flipped the axes, and then we said, we want blue pluses. All right. Let us also add my velocity plus to this. This new variable that we've been keeping this whole array into. All right. My velocity plus, again plotted with my time. Flip the axis so that in the subsurface you go depth increasing downwards, and then you could choose anything, say yellow stars. So here we go. You see, you have the effect. You increase the velocity of this blue velocity functions, and each one of them is now a new function. So what if you wanted to export this to a file? What could you do? For exporting this, let us call it my output. A new variable will keep the data. All right, say df. Before we do that, so let's add. So we have a data frame. This data frame is a pandas object, right? Shift enter. We want to add a new column. So what we want to do is adding a new column. Adding a new column to pre-existing data frame. So you say, let us call this new well. So this new well is equal to my velocity plus, and enter, shift enter. This is already done. So we've added a new well column. So I think out of all the things that we've done, I found this functionality very easy and useful, that you get me a file which has a velocity. I'll increase it by plus minus 10%, sorry 1%. In reality we would do a plus minus 1%, plus minus 3%. Keep that in one file and pass it on to the migration guys, the seismic processors. All right. So next we have to export this. So my output is equal to, there is a one line function. I say df dot to underscore csv, and then I'll choose the same old path as before with an r. Alright, so there was already an r in the path. Okay, and say my demo output dot txt, and that should be it. So we have exported this file into the said location. Let us check the output. Wow, this works, and that's our first Python demo. Thanks a lot. Thank you.